welcome back. This is the fourth 6 weeks recap, and you're listening to Mr. Byrd. If you're not my student, hopefully you can pick something up out of this. If you are my student, hopefully this jogs your memory and helps you recall what we just covered. Make sure that you study. These are just meant to jog your memory. Remember that. It doesn't replace learning in the classroom. So the vocabulary that you've seen so far in the fourth 6 weeks is inverse operation, subtraction property of equality, addition property of equality, division property of equality, multiplication property of equality. Well, I'm getting tongue-tied there. And of course, inequality. They are all very significant properties that you should focus on. And you'll notice that we talked a lot about properties in the third 6 weeks also. It didn't end there. So just make sure you can comprehend the difference with the different properties. So let's move on. First one is solving addition equations. If you have an equation that has addition in it, what you're actually going to do to find what the variable equals to is subtract. Like, look at the side that says algebra. You'll notice that even though it's an addition problem, we're subtracting 2 on both sides. So you're doing the inverse to kind of keep things balanced out. Like, to get rid of a positive 2, you would add a negative 2. It makes it go away. And all that's left is x. If you did that to one side, you did it to the other as well. And look at what you're left with. You're left with an x and a 1. X equals to 1. Now with the subtraction of variables, you would do the opposite there as well. So you would do the inverse. So if it's a subtraction problem, you're going to add. For example, here, look on your right, x minus 2 equals to 3. So I'm going to do the opposite of minus 2. Instead of subtracting 2, I'm going to add 2. And that makes it go away, and it leaves your variable all by itself. But you do the inverse on the other side as well, and you're left with 5. So in other words, x equals to 5. If you're kind of iffy on this, go ahead and substitute that 5 where x belongs, and check it out, it works. 5 minus 2 is 3. It's a good way to test your variables. And of course, if at any point you get stuck or you can't keep up with my videos, pause. By all means, pause. Take screen captures. Do anything that you need to help you guys. That's the whole point of this. Now with multiplication, what you would do there is, if it's a multiplication problem, can you guess what you would do? That's right, you would divide. So you see that 3x and that 12? Divide that constant that's alone by the number that's next to your variable. Always do it in that order. Don't do the opposite. And if you do that, if you do 12 divided by 3, you get 4. If you do 3 divided by 3, it's pretty much gone. You're left with just x. X on one side, 4 on the other. Substitute it. What does 3 times 4 equal? Told you it would work. Now, with division equations, it's going to look like a fraction, but remember, that represents division. So what you would do here is you would do the opposite, just like we've done in the other 3. You would multiply in that algebra section 4 times 7, which gives you, sorry about that noise, I just crashed into my desk. You would multiply 7 times 4 and you get 28. And then again, just like the other ones, go back and test it out. Replace that x, that variable, with 28 and see what you got. Did it work? Yes. 28 divided by 4? 7. So again, always do the opposite of the operation that's there. That's how you find your missing variable. Moving on to inequalities, notice how it says unequal. It's almost like saying not equal. In other words, you're not going to have an equal sign. You're going to have an emphasis on less than, greater than, less than or equal to, that's what that symbol means, or greater than or equal to. And you're going to notice that each one has its own little, hints and quirks and different things that will help you identify it. And we're going to get to that in a short moment. But just understand what each one means. I highly recommend you, if you're going to screen capture something, you should definitely do that to this slide because it really captures all the different symbols that you'll be seeing with inequalities. They're very important. So let's go a bit into determining the solution of an inequality. And we're going to see a few examples. First thing, I want you to notice that if it says x is greater than 4, like in the one you see here, it means that whatever number you put in place of x has to be bigger than 4. Otherwise, it's not true. If I put a 5 in there, is 5 greater than 4? Yes, that's a true statement. Here's another one. If I give it to you in words, can you turn it into an actual inequality? Like if it says you must be over 12 years old, what does that mean? It means you have to be greater than 12. And I used A as the variable because of age. We're talking about your age has to be greater than 12. The subtle hint here was the word over. That means greater than 12. Let's look at a different one. What if we're talking about a pony and it says a pony is less than 14.2 hands tall? Well, keywords right there were less than. So they very distinctly gave it away. There was no hidden meaning or anything. It was very obvious. Less than. Again, if you need to, go ahead and rewind and go back to those symbols in case you don't remember which one less than is. Make sure you study those extra carefully. It is a must to know these for inequalities. Because what if you need to put them on a number line, such as right here? If n is greater than 9, first of all, you go to your number line on the number 9 and circle it. Don't fill it in. Don't make a big dark dot because that represents that it's equal to. It is not equal to 9, so you circle it. And they're saying that your answer is greater than 9. So if you look at that shaded area in blue on your number line, it means that it can be any number above 9. 10, 11, 12, even 9.000001. That's still greater than 9. Now, what if you have less than or equal to, or greater than or equal to? That's when you shade in your point on the number line. Because that signifies that it could be 10, for example, in this one. It can actually be 10 or anything smaller. 9, 8, 7, anything. Negatives, anything less than or equal to 10. A little hint also. Notice the direction that your symbol is facing. If it's pointing to the left, you're probably going to shade in the left of your number line. If it's pointing to the right, you're going to be shading in the right side of your number line. Just a little trick. Now, solving one-step inequalities, we're getting into the fun stuff here. It is the same procedures you used with equations. If you have an addition problem, you subtract. If you have a subtraction problem, you add, right? If it's multiplication and so on, we'll get to those. I'm getting ahead of myself, right? I get excited with algebra, right, and pre-algebra. But pretty much you're moving stuff on that in that inequality to get some balance, okay? And you'll notice, like for example here, it keeps it a true statement. Otherwise, if it's not going to stay true, then you might have made a mistake in your computation, or you might have used the wrong number. So let's look at multiplication and division. If you have, let's say, multiplication, well, what's the opposite? You divide, right? So you would divide, let's say, one side, like look on your right side. If you divide 16 by negative 2, you have to divide the right side by negative 2. Is my equation balanced? And did you notice what happened? When you divide by a negative in inequalities, your sign's going to flip. I'm pretty sure I'm going to emphasize that over and over and over when you do this lesson. Or if I already did the lesson, I'll bet I emphasize it quite a bit. When you divide by a negative, the symbol flips. When you multiply, just be careful that you multiply it by the same thing on both sides. Keep it balanced. Coming soon, angle relationships, area of triangles, rectangles, parallelograms, trapezoids, and we're even going to touch on volume of rectangular prisms. You're going to have a lot of multiplying, so make sure you practice those skills. And like always, I will see you soon, guys. Keep up the great work.